Namaste. You all are welcome in today's my class. Today we are going to discuss about subject Science and Technology, Unit 8, Simple Machine. In this unit, today we will discuss about mechanical advantage, velocity ratio and efficiency. Let's proceed forward without any further delay. Simple machine and its types. So, do you know simple machine? Yes, a tool having simple structure which makes our work easier, faster by applying force in more convenient way is called simple machine. For example, just you see here, this is a tin can. Can you open it with our nail? Just simply this? Yes, it is quite difficult. But very simply, if you use a spoon, you can open it easily. Am I right? You can see here, it is opened easily. That means this spoon makes our work easier. Also, as well as we can do the work faster too. And that's why this spoon works as a simple machine. Another term used here is more convenient way. So what is the meaning of more convenient way? Just see here. We can just open this tin can by pressing this spoon closer to the tin can. We can open it by pressing at the edge where you feel easier to open it. Yes, obviously when you press the spoon at a longer distance, and this is called the convenient. More convenient means more easier way to apply force so that we can do more work. Okay, after then let's move forward. So simple machine and its types. On the basis of structure, there are 6 types of simple machines, but here is mentioned only 4: lever, pulley, wheel and axle, inclined plane. And I think you all have heard about screw and wedge, though they are not mentioned here. Can you guess why they are not mentioned here? Screw and wedge? Can you? Let's see this picture. So here if you see, this is a staircase, a round staircase where people used to climb up, goes down. Yes, this is just like a screw, just like a screw. And if you see here, this is inclined surface. This is not horizontal, not vertical, making certain angle. So this is an inclined surface. As the thread looks like an inclined surface, and we can move up again, the threads going down like this one staircase. So this screw is also considered as an example of inclined plane. In the same way, if you see the next one, yes, obviously this is X. So X wedge, you know that wedge, that is one end blunt, another end sharp. So if you see this wedge here, you can see, suppose this is your X, this is your X. If we just divide it from the middle, and if you keep it like this way, it works as a inclined surface. Here, inclined surface. In the same way, this part also form the same structure, inclined surface. So this is inclined, and that's why this wedge is also considered as an inclined plane. That means if screw and wedge are kept in the class of inclined plane only, then we have only 4 types of simple machine. They are lever, pulley, wheel and axle, and inclined plane. As screw and wedge are the, as I have shown you, screw and wedge are the modified form of an inclined plane. Okay. Now, some terms used in simple machine. Though there are plenty of terms, that many of those terms you have already studied. So some more terms. One of them is mechanical advantage. It is clear from the word mechanical advantage. Advantage and machine. Yes, so if we are applying effort to a machine and machine does some work, obviously we use a machine to do that work easier, faster. So there should be some advantage by using that machine. Okay, so mechanical advantage, that is the ratio of resistance overcome to effort applied in a machine. It is simply, very simply, if you want to say, this is the ratio of load to effort. It means how much load we can lift by applying effort. It means load is compared with effort. Okay, so load is compared to effort means load should be divided by effort, and that's why MA is load by effort. Just observe this figure. You can see here a person is lifting a heavy load, that is 2400 Newton load, by using an effort of 600 Newton only. It means he is applying just 600 Newton effort to lift this heavy load. Do you think he would be succeed if he was just using his hand during that time? He couldn't. Good. So obviously, but if you see here, he is using a long rod-like structure. Do you think what is this? Do you know? Good. It is a crowbar. So by using a crowbar, he is able to lift this heavier load by using less effort. This means this crowbar makes our work easier, and that's why the crowbar is a simple machine and it gives us some mechanical advantage. Now, just simple calculation for finding the unit. Okay, so very simply, the value of load is 2400 Newton. Value of effort here is 600 Newton. After then, if you do simple calculation, this Newton and Newton cancel each other. In the same way, this 0 and the 0 cancel each other. Another 0 is cancelled by another one. Now 6, if you divide 24 by 6, we'll get what? Yes, 4. That means 4. Just 4. No symbols are left here. It means 4 is just numerical value. Here is no unit. So very simply we can say this mechanical advantage has no unit. Am I right? Are you clear about it? Very good. So it has no unit because it is the ratio of two similar physical quantities. Load, that is also force. Effort is force. The unit of force and force, that is Newton, they cancel each other and it is unitless physical quantity. Okay. Now, what does it mean by the MVA of a machine is 5? Just see this figure. I think you had calculated or you have calculated this in your mind. So very simply, yes, you got, let's see it. Do you get the same? 2500 Newton, 500 Newton. After then you got 5. After cutting this all, am I right? 0 by 0, again the same process, 0, 0. After 5, 25, 5, 5 is 25. So MA we are getting 5 here. So what does it mean then? Obviously, the person is applying 500 Newton effort to move this 2500 Newton load. Okay, so very simply we can say that it means the applied effort can move 5 times heavier load by using the machine. In place of this, maybe this value will be different. In place of 5, you will have another values, 3, 2, whatever. So on the basis of that, you can change this 5 accordingly. Okay. Now, next topic, velocity ratio. So do you know what is velocity ratio? Do you have any guess? Yes, very good. It is the ratio of velocity. But which velocity? Okay. So for that, the ratio of velocity of effort to velocity of load in a machine is called velocity ratio. Yes. So velocity ratio, that is velocity of effort to velocity of load. Okay. Now, VR of a machine or velocity ratio, that is shortly called VR. So VR of a machine can also be expressed in terms of effort distance and load distance. So let's see how can we prove it. Okay. So in the previous classes, you have learned about velocity. Velocity means distance covered by a body in particular direction by time taken. Very simply, just tell it as velocity means distance by time taken. Okay. So velocity of effort means distance moved by effort by time taken. So distance moved by effort, shortly called effort distance. So effort distance by time taken. In the same way, velocity of load. So that is load distance or distance moved by load by time taken. If you place this value in this formula, what will get? Yes, let's see here. So velocity of effort, that is effort distance by time taken. Velocity of load, that is load distance by time taken. Now just see this figure. In this figure, you can easily see here a load of 100 Newton is lifted by using 80 Newton effort. Usually in a simple machine, we apply less effort to do more heavier load or to lift more heavier load. So this 1000 Newton can be considered as load and 80 Newton as effort. Okay, a smaller value should be chosen for effort. So this effort was previously here, and 80 Newton effort when applied to this simple machine, then the load is lifted from point C to D. This 100 Newton load is shifted from point C to D. Means distance moved by effort is A to B. Distance moved by load is C to D. But if you think about the time, both the cases, time taken to move from point A to B is equal to the time taken to move the load from C to D. As time taken is same, so we can cancel this time taken. And after then, obviously, we get the result. VR is effort distance by load distance. Okay, now a bit more. I want to make it a bit another definition formula. Just see here in the above figure. If you just you are remembering about the similarity, then I want to show you one other relation. Okay, so this and this as they both ABF and CDF, they can be considered as similar triangles, and you have learned their sides are proportional. So if you see here AB by CD, AB, one of the, let's write this triangle part first and this triangle part second. So AB by CD, this side should be proportional. Okay, so this side should be proportional to the next one, FB and FD, or we can say BF and DF. Though there are another side also, this FC and FA, we don't require that, so I am not going to explain about that. But this FB and FD we can show. So from this similarity, we can write AB by CD, that is equal to BF by DF. So if you see here BF, what is this BF? Yes, this is the distance between fulcrum and effort. DF, this is the distance between fulcrum and load. So same thing is written here. VR is distance between fulcrum and effort, because BF, if you see here, BF is a distance between fulcrum and effort, In the same way, df is the distance between fulcrum and load. So velocity ratio of a machine can also be defined as the ratio of distance moved by effort to distance moved by load. It is simply the ratio of effort distance to load distance. It has no unit because it is again same. Both are distances, both are velocities, so they have no unit, and that's why this one velocity ratio also a unitless physical quantity. Okay, just keep it in mind. It should be noted that VR of a machine is always greater than its MA. First I want to know, do you know about this? VR of a machine is 4. What does it mean? If VR of a machine is 4, what does it mean? So, obviously, very good. That is, distance moved by effort is 4 times longer than the distance moved by load. Yes, effort distance 4 times longer than load distance. Very good. Now, so I want to give you a question. Let's think it. Why is VR of a machine greater than MA? Do you have any guess? Okay, very good. VR of a machine, VR is not affected by friction, but MA is affected by friction. It means some of the energy, some of the work is wasted to do work against friction. It means in case of MA, as it is affected by friction, some energy wasted. But in case of VR, no energy is wasted, and that's why MA is less than VR or VR is greater than MA. Okay, so I have a numerical problem here. Just let's solve it. So here is a wheelbarrow. You can see here 2000 Newton load that is lifted, shifted by 800 Newton effort, and this is fulcrum. This is the load place, and that's why distance between fulcrum and load, that is called load distance. And this is fulcrum, and this is the place of effort applied, and that is effort distance. So how to find MA and VR? Let's see it. First, we want to find MA. So in case of MA, we require load and effort. So if you see load, how much? Load 2000 Newton. Effort, how much? 800 Newton. Good. So after then, we have to calculate MA. MA equals to how much? Load by effort. Load 2000 Newton. Effort 800 Newton. This Newton cancel, 0, 0, 0. And then 2 4s are 8, 2 10s are 20, 2 2s are 4, 2 5s are 10. This is 5 by 2 means 2.5. Therefore, MA equals to 2.5, and it has no unit, so no need to mention it. How to find then VR? Okay. For VR, we require effort distance and load distance. So effort distance, that is ED. Effort distance is how much? From fulcrum to effort. So 1 meter. Let's leave it as it is. Load distance, that is distance between fulcrum and load, that is 40 centimeter. So convert it in SI system. 40 by 100 meter, it will be 0.4 meter. Now VR. So VR equals to ED by LD, effort distance by load distance. That means 1 meter by 0.4 meter. This meter cancel. After, if you do simple calculation, you will get again this is 2.5. Just okay. Therefore, VR equals to 2.5. It means VR has also no unit. Okay. Just I want to go through the brief summary, whatever we have learned till now. So just we have learned about simple machine, their type. After then, we learned about there are only 4 types of simple machine: if we consider screw and wedge as the modified form of inclined plane. After then we discuss about MA, mechanical advantage, that is ratio of load to effort. It has no unit. Then we learned about velocity ratio, ratio of velocity of effort to velocity of load. After then, that is modified, or we just derived another formula, VR equals to effort distance by load distance, or the ratio of effort distance to load distance, and then we have just done this numerical. So this is all about whatever we have learned till now. Okay, now let's move forward. The next term is input work, that is the work done by effort in a machine is called input work. Okay, so work done, you know about work. Work is the very simple formula, work equals to force into distance. Here is input work. It means also here this is work. So again here is the product of force and distance. So it is in the product form. We can see here it is the product of effort and effort distance. Effort, just keep it in mind. Effort is force. So force into distance, and we have learned work is the product of force and distance. That's why input work is the product of effort and effort distance. And the unit of work is joule. Input work is work. That's why its unit is also joule. Input work, effort into effort distance. Okay. Now next term, output work. Output work, like input work, the work done by load in a machine is called output work. It is the product of load and load distance. Just like input, you can replace by output work. In case of that, we have to choose load and load distance, and its SI unit again joule, as it is work. Okay, so input work, that is work done in a machine, and output work, work done by the machine. So obviously we have to use some input to get output, and that's why output work, maybe that will be less than input work. That I will explain it later. Output work, again that is work is the product of force and distance. Load is your force and load distance is the distance. Now the next term is efficiency. So just see this two cyclists. One of them is riding the cycle quickly, but another is feeling tiredness. Yes, this example shows the efficiency, okay, of that machine. So first case, so what is then efficiency? Yes, in first case the person is riding his cycle quickly. It means the cycle has more efficiency and he is able to ride it easily. But in the second case, he is feeling tiredness because maybe his cycle has less efficiency, and that's why means he is not able to produce more and more output work. He is not able to move his cycle quickly, and that's why we can say it has less efficiency. Okay, so efficiency is nothing. How that is the just ratio of how much output work you can do by using the input work, or the how much work the machine does by using the input work. Okay, it is generally expressed in percentage. That's why efficiency of a machine is represented by, this is Greek letter eta. Okay, so Greek language, that is eta symbol is used to represent efficiency. Now efficiency, eta is output work upon input work, and as it is represented or expressed in percentage, so 100 is written here. After then, obviously output work, the unit is joule. Input work, the unit is joule. So the unit cancel each other, and that's why efficiency has again no unit. So MA has no unit, VR has no unit, efficiency has no unit. Now, so efficiency of a machine is highly affected by the factor that is friction. So if you want to increase the efficiency of a machine, it means we have to reduce the friction. How can we reduce the friction then? Okay, so if you see here, ball bearing is used, grease is here. You have, I think some of you used to put that one, use cycle, sorry, you used to put mobile, then oil in the movable part. So you know that by putting that, the efficiency is increased, or you are capable of riding that cycle or other devices easily. So by using lubricant, means lubrication helps to reduce the friction. In the same way, if you are using ball and bearing, obviously rolling is easier than sliding, and that's why ball bearing helps to reduce the friction. Next one, making the surface smooth. Yes, you know that when we step over a soap kept in the bathroom, then we slide. The reason is there is more smoothness on the surface. It means if surface smoothness is increases, that case we are able to reduce the friction. So these are some ways to reduce the friction, and by using by reducing these factors, by lubrication, by using ball and bearing, or by making smooth surface, we can reduce the friction. And if friction is reduced, obviously efficiency will be increased. Okay, so though there is no existence of any perfect or ideal machine till now, but we don't know about the future. Okay, so till date there is no any perfect or ideal machine. What is the ideal machine? Yes, the machine which has 100% efficiency. Till date there is no any machine that has efficiency 100%. Okay, now how can we prove the following? Efficiency eta equals to MA by VR into 100%. Let's see here. So we have learned efficiency, that is output work. Just we have output work by input work into 100%. Output work we have learned load into load distance. Input work effort distance. Let's separate it. Load by effort. Load distance by effort distance. Load by effort, we have learned this one, load by effort, that is MA, mechanical advantage. And load distance by effort distance, we don't have such formula, but we have the formula of effort distance by load distance, means reciprocal of this. That's why reciprocal we can write here effort distance by load distance, that is VR into 100%. So MA by VR into 100%. That's why efficiency equals to MA by VR into 100%, and this is widely used while doing the numerical problems. This formula is widely used. Okay, I think you all are clear about it. Let me rub it. Now, so one question here, write two differences between input work and output work. I think you are able to write about that. Input work definition you can write, output work definition, then after then input work less, input work more, output work less, formula is there. In the same way, efficiency of a practical machine is always less than 100%. The machine which we use in our daily life, they are practical machine, and practical machine is affected by friction. The sum of its energy is wasted to do work against friction, and energy is wasted in the form of heat energy, sound energy, and other forms. That's why efficiency is less than 100%. Next one, efficiency of machine is 90%. Obviously 90%, that machine can convert 90% input work into output work, and remaining 10% is wasted, again like the previous one, to do work against friction. What is perfect machine? We have already discussed about that. There is no any perfect machine, but hypothetically we can say the machine having 100% efficiency. And why is it called practically not, why is it practically not possible? Obviously till now the machine is governed, they all contain some friction, and so it is practically not possible. Now we have next numerical problem. Let's see it. Okay, so we have a figure here. If the length of crowbar shown in the figure is 1.2 meter and distance between fulcrum and load is 20 centimeter, then find its MA, VR and efficiency. So again, if you remember the previous solution, I think you are able to solve this. Okay, so number one, we have to find MA. For MA, we require again load. So load L, that is how much given? This is 2500 Newton. Effort E equals to how much? 500 Newton. So without any delay, MA equals to load by effort, that is 2500 Newton by 500 Newton. Newton, 0, 0, 0, these all cancel each other. So 5, therefore MA equals to 5. Now we require to calculate VR. So VR effort distance ED. Let's search there. Is there effort distance? Means fulcrum, distance between fulcrum and effort. Oh, there is no distance between fulcrum and effort. Whole length is given 1.2 meter, but distance between this, only this much is not given. It means we require load distance. Okay, so first let me to do about load distance, and then I will explain about effort distance. Load distance, that is LD equals to 20 centimeter. Okay, so 20 centimeter, that means 20 by 100 meter, that means 0.2 meter. And now if you are moving to effort distance, then ED equals to how much? Just see here, total length 1.2 meter and this is 0.2 meter. So length between fulcrum and effort, that is 1.2 meter minus 0.2 meter. Am I right? If you see in the figure, total length 1.2 meter and this is 0.2 meter. So this length will be only this length will be 1.2 minus 0.2. So this will be 1 meter. So now VR equals to ED by LD, that is 1 by 0.2, it is 5. So VR equals to 5. Oh my God. Here we got MA 5, VR 5. Usually this is not possible in the practical machine, but in case of lever it can be considered, but in practical life it is quite difficult to get MA and VR equal. Now efficiency MA by VR into 100%. So obviously MA we have 5, VR 5 into 100%. This is 100%. As I have already explained about this, efficiency 100% is practically not possible, but mathematically we can. Okay, next numerical. We have next numerical. A simple machine is used to lift 1200 Newton load by using 400 Newton effort. If the distance moved by load and effort are 4 meter and 14 meter respectively, then find input work, output work and work wasted. Okay, so now let's do the solution of this numerical. So solution, okay, data. Load how much given in the question? Load L equals to 1200 Newton. Effort E equals to how much? 400 Newton. Distance moved by load, that is called load distance. LD, what is that? 4 meter. Good. And effort distance how much? How much? Effort distance, that is ED. Yes, good. 14 meter. So now we have to find input work and input work. So input work, that is, what is the formula? Good. E into ED. So E how much? 400 and ED is 14. So 14 for the 56, 0, 0. I am writing here joule. Output work, what is the formula? Good. Load into load distance. So load how much? Load 1200. Load distance 4. That is 4800 joule. Now if you see here, input work 5600 joule, output work 4800 joule. It means here are some and work wasted, and that difference work wasted, that is 5600 joule minus 4800 joule, and that will be 800 joule. And in this way we can find input work, output work, and work wasted. Okay, so after then let's do some multiple choice question or some objective question, we can say. So find the correct alternatives. Which of the following is a simple machine? Scissor, bicycle, sewing machine, or scooter? Which one? Do you have any guess? Yes, scissor. Okay, the next question. What is the mechanical advantage of a machine if 1800 Newton load can be lifted by using 600 Newton effort? So again, just calculate in your mind 1800 load, 600 Newton effort, and then see the options. 3 Newton, 1 by 3, 33.33. So 1800 by 600, that is 3. Newton cancel. Oh, both are 3, but here is no unit. So this one is the correct. Good. Next one. Which of the following physical quantity has unit joule? Do you have any guess? Mechanical advantage? No. Then efficiency? No. Velocity ratio? Or which one? Output work? Yes, you told output work. That is the correct option. Now moving to the next one. Which is the efficiency of a perfect machine? Perfect, practical, no sorry, perfect or ideal machine. Which one? That is 100% efficiency. Okay, so these are some multiple choice questions. Now you have two other questions that you have to do in your copy and you have to show to your subject teacher. These questions are, let's see. Number 1. Suppose you have two scissors X and Y of different shapes and sizes. Scissors X has longer report arm and scissors Y has shorter report arm in comparison to load arm. Which scissor will you prefer to cut the thin sheet of zinc? Similarly, which scissor will you prefer to cut a piece of cloth? Write the answer with suitable reason. You have another one. A person wanted to lift a heavy stone with the help of 3-meter long crowbar. Initially, he kept a fulcrum 50 centimeter away from the stone to lift it, but he couldn't. After then, he kept the fulcrum 15 centimeter away from the stone and he applied force and he succeeded. How was it possible? Write with suitable reason. So these are two questions I am leaving for you and you do the solution, show to your subject teacher. Just before sum up the class, I want to recall whatever thing we have learned today. So today we have learned about simple machine, then types of simple machine, then different terms, MA, mechanical advantage, velocity ratio, VR, then efficiency. After then before discussing about efficiency, we learned about input work and output work. That is input work, the work done by effort, output work, the work done by load, and MA, VR, efficiency, they don't have any unit. After input work and output work, they are work, that's why they have unit joule, and then some numericals. Okay, I hope you all are clear about today's class. Okay, so thank you and namaste again.